problem from the preface section of In Pursuit of Zeta 3. So this book is written by the Paul J. Nahin, and the book is awesome, and this problem is also good, and the way I'm going to solve it is using the digamma function, and I hope you will enjoy the solution. Right, let me start. And recently I have been quite busy with my transferring to the university. I'm just starting my bachelor, so there was quite a lot delay in the upload of videos, but I promise that now I will be really prompt, and I will not make a logging gaps as I had. Okay, so now let's start solving this integral. We have integral from 0 to 1 x to the power 5 ln of 1 plus x dx. Now how I can simplify this integral is by using the Taylor expansion of the logarithm function. We know that if the magnitude of x is less than 1, which is of course the case because the integral is going from 0 to 1, so x is going from 0 to 1, right? So I can use the sum formula for log 1 plus x, which is just the sum from n equals to 1 to infinity minus 1 to the power n plus 1 x to the power n by n dx. Yeah, now since the sum is in the world of n, this can be taken inside, and then we can interchange the sum and integral. So we will have sum from n equals to 1 to infinity, integral from 0 to 1, and then minus 1 to the power n plus 1 x to the power n plus 5 by n dx. Now we can interchange the sum and integral, which I've already done. Now I can take the integral. Sum from n equals to 1 to infinity, I can take this minus 1 to the power n plus 1 by n outside, since they are just constants. Now if I integrate this, I get x to the power n plus 6 by n plus 6, and this is going from 0 to 1, right? Now this is easy to evaluate. We have all done this sorts of integrals. Minus 1 to the power n plus 1 by n, and this is just 1 by n plus 6. Now I will just do the partial fraction decomposition, right, so that I can simplify this sum. 1 to infinity minus 1 to the power n plus 1, and this will just be what will it be, 1 by 6 taken out, and then 1 by n minus 1 by n plus 6, right? I think that's going in a good direction, I guess. Now how do we sum this up? This seems like a telescoping sum, but this alternating sign thing is making things complex, right? If we did not have that, then it would simply have been a telescoping sum, and it would not really have been a problem to sum them. But in this case, it seems like there will be a problem, right? Yeah. Yeah. Now minus 1 to the power n plus 1, we have n 1 by n minus 1 by n plus 6, right? Okay. Now what I actually want to say is, if you just try to sum this thing, if you just try to sum to see how this sum goes on, you might notice that. Now you might notice that this will be okay. So 1 by 1 for this one, 1 by 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 plus 1 by 5 minus 1 by 6 plus 1 by 7 minus 1 by 8, and it goes on, right? And minus, again, this will just be 1 by 6, sorry, this will just be 1 by 7, right? Sorry for that. Minus 1 by 7 plus 1 by 8 minus 1 by 9 plus 1 by 10, and so on. So we can clearly see that things are cancelling over here. This 1 by 7 cancels, minus 1 by 8. Sorry, here's error in the sign. Wait, minus plus minus. Okay, now things are actually cancelling over here, right? Things from 1 by 7 will just cancel out, and this is the only thing that remains. The other thing will cancel out. So what I can say is this will actually just be 1 by 6 times 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 plus 1 by 5 minus 1 by 6. I had actually planned to use diagramma to simplify this, but yeah, it works out pretty easily even just by the common sense, right? Now how do we sum this up? The summing this up isn't really a big problem. You can just add these two numbers, or also there is a good idea to do this, which is actually there's an identity which says that 1 minus 1 by 2 plus 1 by 3 minus 1 by 4 plus 1 by 5, this thing, minus, okay, it goes up to, let's say, minus 1 by 2n. This is actually just equal to 1 by n plus 1 plus 1 by n plus 2 up to 1 by 2n. Yeah, there's an identity. We can prove it using induction. Yeah, and I can also easily prove this. What we can do is we can just group these odd and evens, right? If we do that, if we just group the odd and evens, or let's say yeah, okay, if you just group the odd and evens, what we get over here is 1 plus 1 by 3 plus 1 by 4 plus 1 by 5 up to 1 by 2n plus 1, and then minus 1 by 2 times 1 plus 1 by 2 up to 1 by n, right? So we can see that, okay, over here from the odds the whole thing is getting subtracted, right? And that means, okay, now I can just, let me just take 1 by 2 common for now. Okay, if we just take 1 by 2 common, okay, now okay, wait, what I can do here, let me see what I can do. Okay, now what I can do is I can just add this 1 plus 1 by 2 plus 1 by 3 plus 1 by 4. I can add all the way up to 1 by 2n, and I can again just subtract this, which is again just minus 1 by 2 times 1 plus 1 by 2 up to 1 by n, and again we have the same thing over here, right? Okay, now this is how, so this is sum from 1 to 2n, and there are two of the sum from 1 to n, so that's why the sum from 1 to n cancel out, and we will have sum from 1 by n up to, 1 by n plus 1 to up to 1 by 2n, which is exactly what is over here. And this can be written as just sum up to 2n, right? Sum up to 2n minus sum up to n. As means just the harmonic series, which is the inverse of natural numbers. So what we did to prove this was just add these numbers. So first of all, just add these all numbers, right? Up to 2n, just make the plus sign, and these minus ones will be subtracted 2 times. So that will just be minus 1 by 2 minus 1 by 3 up to minus 1 by n. This is how we got this formula. Now we can also use that formula to easily sum it up. That means this will just be 1 by 6 times 1 by 4 plus 1 by 5 plus 1 by 6, and that will just be 120, right? We can also have 60, I guess. 60, 15, 12, 10. That is 37 by 360. Wait, 37 by 360. Yeah, 37 by 360, which is 74 by 720. Right, there are some answers. Okay, so we have solved this. This is the answer, 37 by 360. Let me write it over here. 37 by 360. 37. Yeah, these are correct. So we have solved this integral, and I was planning to diagram function because I had solved it in copy using that, but over here there was no real use because it was just some alternating telescoping sums. Yeah, and yeah, this is how the problem is solved. Hope you enjoyed the solution. Thanks for watching.